Hi, welcome to the Sunfiber channel. Today with me is Bryce Meyer, who is a professor and has been studying space agriculture and robotics. And we're going to have some conversations about that. So let talk about your background. What kind of space things have you been into? How did you get into space
Hey,
industry?
yeah, I've been into space since I was a child, since I'm a huge fan of sci fi and have been forever. I've got a degree in aerospace engineering and another one in computer science software engineering and another one in biology,
Oh, wow.
right? I'm all over the map degree wise. I started off in the Air Force. I was in the U.S. Air Force for about 7 years active duty. I got out. I worked in all kinds of internet tech and eventually worked for Carnegie Mellon University and doing aerospace research for them for Department of
Oh,
War, NASA, stuff like that. So I've worked in that industry a long time. And then now I teach half time for Franciscan University, like I said. So I've been into space agriculture since forever, right? The reason is I think one, there's no comprehensive strategy for doing it. Everybody thinks plants and stops there, right?
yeah.
And that's not how it works. I used to work on my grandparents' farm, right?
Right.
And I live in O'Fallon, Missouri, which is bigger now, but has farms everywhere. And
Yeah.
so I've worked with lots of farmers and stuff, and it's not a whole lot of a stretch to think, hey, farm, space, sci fi, we got to have something to eat every day, right?
Yep. Yep.
And space settlement to me, I look at it as trillions of happy, smiling babies in the future, right? So you
Okay.
can't get the trillions without having at least 100 Earth equivalents somewhere. And for me, that comes from Genesis, of course. I happen to be a religious man, and that's how I go. But there you go.
So your work in compact photobioreactors?
Yes, one of the unappreciated technologies for making sure you close the mass loop. So everything in space settlement comes down to this, right? It's expensive to ship mass up into space. Even if we get starships, it'll still be much more expensive than taking it down the road and buying it from the supermarket, right?
Oh, yeah.
So due to that cost factor, you have to close the mass loop. One of the ways to do that is using something like algae, right? Where you take algae and grow them in a series of machines called bioreactors. And a bioreactor is a combination of machinery and biological organisms, right?
Okay.
Usually bacteria, yeast, or algae, something that you can grow in that. And then there are different kinds. There's some kinds that are membrane based, where you have the organisms attached to membranes and you
Hmm.
put them in various high surface area structures, or you have them in open vats, which is the most common. Now, bioreactors sound like a scary thing. You use them
Yeah.
all the time. I'll tell you about several kinds you use every day, right? So, one, if you drink beer or wine, that's what a fermentation vessel is, a
Oh,
bioreactor.
oh, okay.
If you had anything with xanthan gum in it, or a wide variety of pharmaceuticals you eat every day, or a lot of things that you put in different foods and vitamins and things,
Hmm.
bioreactors. My brother works in that field, actually.
Oh,
And so algae are just one more kind. So people use algae bioreactors, the open variety, to feed shellfish on the East Coast. If they have shellfish farms, they use it for that.
okay.
So we probably didn't know that either. And then it's used for carbon sequestration, as you see a lot. You also see it for biofuel production. So these are established technologies, but making them small and then eventually putting them in space, that'll be a challenge, right? Especially when you're talking 1/6 G versus 1/3 G, because stuff has to settle out.
Yeah.
And so photobioreactors were something I've played with, let's say. I've come up with several different designs. I put them all in my books because I honestly haven't been able to go through the full prototyping process of getting really cool with them. But several have been on the ISS from other companies, right? Several companies have produced different types of photobioreactors and put them in there. And the big reason is it can take in the CO2, release oxygen, and it's a small size. So I can actually use that instead of just using something like zeolite to get all the carbon dioxide and stuff out of the air and
Yeah.
then recycle it, just like a plant does. A plant does the same thing, of course, right? And so that's essentially what we're talking about, something that's very small and can do a lot of mass pushing, taking CO2 and pushing out oxygen, and at the same time, creating biomass that I can use for different purposes, right? Now, you could eat the glop, Lord help you. I wouldn't recommend it, but
Yeah.
you could in a lot better farm scenarios. You use it for creating different additives, use it
Yeah.
for creating oils, right?
Okay.
Or you feed it to something that you eat, right? So one of the things you can feed it to, of course, is shrimp and fish, right? Which in a longer term scenario, those would be great things to have in
Oh, yeah.
space. because they're very good at turning things that you can't eat into things you want to eat. Right, that's what those type of organisms are good for. They actually close the mass flow loop very well. Right, so that's why you look at photobioreactors. Right, so a photobioreactor is a bioreactor with light, and then whatever shape gets you to the point where you have lots of light at the right levels with lots of organisms, you get lots of production.
Would you be able to produce fertilizers and stuff for plants?
It could produce the mass for that, but there's one problem with that. If
Yeah.
you're creating that kind of soil, then you're losing the carbon out of the air, and now you're going to have to replace it.
Oh, because it's stuck in the soil now.
Right, especially if you're talking a rotating habitat, right? Everything in a rotating habitat is closed,
Yeah.
right? Ideally, right? Ideally, you try to close that loop as tight as possible. And so if you're creating soil, living soil, then it's going to cost you carbon and other mass from somewhere else.
Oh,
Right.
yeah.
But with the algae, if you eat them or you feed them to something and then eat those, then you're closing that carbon loop through you. Right.
Oh,
Everything. So it's a gazindas and gazaudas problem, right? As my grandpa would say. Right. Everything that is a gazinda becomes a gazauda, and everything that goes out of you has to go through the space farm and all of its machinery and all that stuff and come back in as a gazinda.
yeah. So if you had farms anyway already, that you'd be able to use this to produce like fertilizer and whatnot as
For a wide
one of the
variety of things.
byproducts.
Yeah, one of the big things I think you would actually use it if you're not going to feed it to an animal and you need it. One, it's a backup. So let's say all the plants die,
All right.
right? Then you can survive for a while on algae. You could take the algae and feed them to yeasts and eat the yeasts, right? So between the two of those, the glop and I hate to say it, glop and glop, right? Your yummy, wonderful glop and glop diet will keep you alive until you can get everything restarted again. Right. So one, it's a backup if nothing else, combined with a yeast bioreactor, right? Some kind of fermentation vessel with a combination of bacteria and yeasts. The two of those together will produce enough to keep you alive. Right. So one, it's a backup. The
Mhm.
other purpose is oil. So you need oils just for cooking,
Yep.
right? Just for salad dressings, right? You can actually make noodles out of algae, right? So they could be an additive to your farm, right? They're one more way of twisting things and making them. Now, the regular bioreactor itself, the yeast and bacteria bioreactor, which could be anaerobic or aerobic, is like the Swiss Army knife of closing your mass flow loop organically, right? So instead of having to burn everything to get carbon back or get water
Yeah.
back, you can actually use those bioreactors to get all those extra things you need, right? So you come through and you have crop waste. You need to digest the crop waste and do something with it, right? To recover the carbon and the water. So
Yeah.
you could send it through bioreactors to do that, right? You can create extra water, extra carbon dioxide to feed your plants.
Can you do that with plastics too?
Yes, you could digest plastics, though you could also use mealworms for that too. Worms are really good at plastics. If they're organic plastics that are going to decompose anyhow, then yes, a bioreactor would be a great way to do that.
Okay.
If they're inorganic plastics, I wouldn't add them to your mass flow. They're just something you incinerate to get whatever out of it and call it a day.
Right. Okay.
So usually your farm is more than just the plants that you eat, right? So you have the habitat that puts into your waste processing, right? Waste processing usually involves settling out things,
Yep.
starting bacterial digestion, right? And go through a battery of settling tanks to end up with very thick sludge at the bottom and then nutrient rich water at the top. Now you
Okay.
can sterilize that water, and now that goes into your plants. That's something you send through the rooterate in your plants, right? And once the plants use it, now it's going to be clean because it could come out through transpiration that you recondense and send that back through as clean water, right?
Yeah.
Or it goes into the plant and you eat it.
Yeah.
Or it goes into plant waste, and again, you send it back through another series of bioreactors to digest it.
Okay.
Now, one of the problems with space settlement is everybody worries about the oxygen, right? Oxygen is not the problem. That's far from your problem. So
Okay.
you don't exhale enough. If you have, let's say you had the perfect garden, right? Produced everything you ever wanted to eat, you don't exhale enough CO2 to keep yourself alive for very long.
Oh, yeah.
Nope.
Need more CO2 than.
Then you exhale. You do,
Yep.
right? And the reason is because it gets occupied in all the parts of the plant you don't eat.
Yeah.
Eventually, all that carbon gets sequestered in the parts of the plant you don't eat. Plus, you got to crack your poop. So once you eat something, a lot of carbon is in your output, let's say, and
Yes.
you've got to crack the output to recover the carbon dioxide and water again. So it's not as simple as just having a magic farm, right? You have to have something that does that cracking, that takes human waste and processes it, which is called black water,
Yeah.
but also takes the crop waste and processes it, even if you had perfect amount of plants, right? So even if you had a perfect diet with a perfect farm,
Yeah.
carbon is your problem, not oxygen.
That
It
makes
doesn't
sense.
take very much green mass at all to cycle the oxygen for that you breathe. Very little. Another interesting thing is humans actually release more in what they breathe and sweat than they
Yeah.
do in their pee. Right? Your
Yeah.
kidneys are vastly efficient at taking water out and releasing only as much water as they have to.
Okay.
Right? So as a result, your breath has a ton of water in it, and so does your sweat. And you have to condense that out, and you can use that straight up in where the human living areas. You have to do that anyhow to control the mold growth,
Yes.
right? That's part of your cycle. The other thing is your wash water is gray water, right? You can take that gray water, and farms don't just have to be in a separated area.
No.
Some plants can be grown in the habitat as part of your water cycle. So, for example, right now the ISS is stinky, right? So, we're going to go into a can. We don't want stinky air. We want air that we want to breathe, right?
Yes.
And
Yeah.
so, to do that, you're going to have corner plants. You're going to have plants around poles. You're going to have plants growing on the tubing and aisleways inside of different areas, right? If you have an area that's a corner or handrails, things like that, you might have green walls everywhere in a habitat because one, you like to see green. It's good for you,
Yes,
right?
it is.
The other
Pretty
side
much.
is it cleans the air.
Oh, yes.
So the air will smell far better. And then the biggest benefit is I can take that gray water, send it as a tap into the root bases of every one of those plants. And
Hmm.
then the plants do a magic thing called transpiration. So they release hundreds of times the water they incorporate. So what
Okay.
happens in transpiration is that evaporation pulls. That's how plants circulate. Evaporation will pull the water from the roots and pull the nutrients up into the plant. The
Oh, okay.
plant photosynthesizes. Some of the water is incorporated into the plant. Some of the water is released into the air. So if you already have condensers in the habitat, because of all of us sweaty apish animals that are wandering around, right? And maybe our pets, who knows, right?
Right.
Anyhow, yeah. So all of that water has to be condensed out anyhow, right? You might as well condense it and directly circulate it from the plants as well. So you can now directly recycle a lot of the gray water. And now the only thing you're sending to the farm is waste and extras, right? That's the other water that you're sending there, right? Your waste
Yeah.
and extras. So black water and then whatever extra water that you cycle that you need to process.
So on Earth, plants are all putting water into the air. All the animals are putting water into the air.
Yep.
So it rains. That's how
Yep.
we get the
That's
water out of the air.
exactly what happens. That this is a natural cycle. And most of the whole things about recycling mass in a space farm or in a habitat, that whole mass flow cycle happens on Earth. It just takes longer.
Yeah. Yeah. Yeah.
The soil is a giant bioreactor. It's a huge bioreactor, right?
Yeah.
It has insects, it has funguses, it has bacteria. It digests things over time. The lignin, which is the woody parts, get digested by funguses, which the bacteria turn in. Cellulose gets directed by bacteria. Worst comes to worst, you have a wildfire that takes out the rest, right?
Right.
And so those are all part of the natural cycle on Earth already that does that mass cycling. Sweat comes out of us, all of us animals release it, and yes, the plants mostly are the largest source of the water that gets back into the air that isn't directly evaporated off open bodies,
Okay.
right?
Yeah.
And the soil, remember, releases water too. So the soil is its own aerobic bioreactor, combination of anaerobic and aerobic in combination, right? And so the
Yeah.
soil will take all that cellulose and all that material that's in the soil, takes in oxygen to some degree,
Mhm.
and then releases carbon dioxide and water back into the air. And
Yeah.
that's closes the plant cycle. Because what are plants? Carbon dioxide and water,
Yeah.
mostly.
So on a space station or space habitat, we want to make the loop smaller than it is on Earth. This kind of thing.
And the
Shorter.
bigger the space settlement, the more complicated a loop you can get.
Right.
Eventually, once you have enough menu diversity, so menu diversity is one of the things that drives a space farm, right? People
Yeah.
go nuts if they don't have good food.
Oh yeah.
Boom.
Yep.
They'll go insane and they'll start losing weight and they'll get depressed. And this has happened to some of the Chinese studies where they've locked them in and fed them just a simple plant diet. Yeah, they lose weight. They didn't
Okay.
publish it. The rumor came out of China other way at 25% of their body mass, plus or minus. Nobody's confirmed that, I guess. I wouldn't think they'd advertise it per se. It might be buried in their paper somewhere. I
Okay.
couldn't find it directly in the papers, but they did cover the fact that they did successfully get full mass cycling in their system.
Okay.
So they've proven that in the Chinese study, right? And as a result, menu diversity is a thing. So
Yes.
the smaller the settlement and the earlier the settlement, the simpler the menu is going to be, plus whatever you shipped in already, your initial food source, right? So
Yeah.
for a while, if you want anything beyond glop and some simple salad greens, guess what? You're shipping it in, right? But
Okay.
after a while, what happens is the farm gets bigger. You start
Yeah.
enhancing the size of the farm, you add a lot more crops. And what happens is the mass flow actually mostly then happens inside the farm parts. So the
Right.
mass flow cycles inside the farm itself way more than just going from human to farm and back again.
Yeah. So
And the
like,
reason is because that menu diversity, crop diversity, ends up driving a lot of the mass flows in the remaining part of the farm as it gets bigger. But the
yeah.
upside is now I can make almost anything, right? If I have 10 possible crops that I produce, including mushrooms, including possibly shrimp or fish, that lots of oil crops like soybeans or peanuts, calorie crops like potatoes and rice,
Right.
those kind of things. If I start adding a lot of those options plus different kinds of vegetables, and eventually start talking about longer lived things that I want to produce. Because initially, you might have a coffee bush, you're not going to get a lot of coffee. If you like chocolate, you're in trouble.
That's
If you
hard.
like cinnamon, you're in trouble. It's going to
Okay.
take a while, right? Those are all tree things.
Yep.
But things that are not tree things that you can grow in within a year, within 2 years, you should be able to get some of the things like coffee, right? That shouldn't be out of the question at all, right?
Yeah.
And citrus, now you're thinking, well, what about citrus plants? Well, it only takes a couple of years if you start off with a sprout this big to start getting citrus, right?
Yeah.
As long as you have the room. And citrus plants are great house plants. They're a great gray water tapper, right? Take the gray water, put it in the roots, pick your own limes, lemons. In a big settlement, you start talking about parks
Yeah.
where you have big open grassy areas, or not grassy maybe, but jungly, grassy, planty areas for people to hang out in and just walk through and work in.
So when you're saying size, are you saying 100 people would be enough to start making interesting meals, or like 1,000 people?
Yeah, really, 100 is about 50 to 100 is where you start getting much more complicated menus per se because you have a lot more mass flow. But even with 8 people, you could start growing a lot of these side plants and add them to your diet. So
Yeah.
things like the citrus plants and the coffee plants and things you could even grow with 8. It just takes time, right? And then the next question people ask is, what about labor? Well, I'm going to tell you this. If people are working all day staring at a screen, they're going to want to volunteer to work in the gardens and the farm. You're going to
Yeah.
have more volunteer time than you know what to do with, right? And you can augment that with artificial intelligence systems in agent forms, different agent sized artificial intelligence systems that'll keep most of the basic parts of the farm running, keeping the water flowing to the roots, monitoring all the crops, doing things that can flip switches and things that can keep things running normally, right? Keep the light running, keep the heat at the right level, keep the humidity level, right? Those are all AI manageable even now. So that's not that complicated. That technology already exists, but you're going to want people who are going to trim leaves, harvest vegetables, pop tomatoes off the vine, maybe even do some wheat harvest, right? If you got a lot of wheat, okay, now we got to talk about something more complicated. But if you just got a little bit of wheat or a little bit of rice, that's not that hard, right? You can take some kind of mower and shear it off and take it in with you, right? You can have your own little minor harvesting section, right? That
Oh yeah.
deals with things. Yeah. For a larger scale, yeah, we start talking robotics and things like that too.
Okay. So
But
let's talk robotics then. But dealing with robotics.
honestly, I've done a lot in the Department of War with robotics,
Oh,
UAVs,
yeah.
UASs, satellites, right? That kind of thing. On a farm, robotics has just started to appear. It's most of the
Right.
automation on farms nowadays is with combines directing UAVs to collect data or to drop fungicides, drop pesticides, drop herbicides. That's where it is on Earth now. That is the state of the art. In a farm, what you're going to have is more of the industrial variety, where you're going to
Okay.
have
Yep.
arms on tracks, right? And you're going to have SCADA systems, right? So I have a lot of experience with SCADA systems too, to some degree, not like my brother who works in that very field, but SCADA
What
system can be
what
required
there?
anyhow.
You call it
Yeah,
SCADA systems?
supervisory control and data acquisition.
Okay.
So that's what controls a pipeline or a factory.
Right.
So space farms in the future are very similar to chemical factories and farms at the same time.
Yeah.
You already see that in vertical farming now. Vertical farms now are highly automated in a lot of cases if they're any scale at all. This is,
Right.
again, technology we already have. This is
Yep.
not something we have to invent. The hard part is going to be moving it to space and see how well it does in different gravity environments or due to
Yep.
centrifugal force in a rotating habitat or due to a radiation environment. But the machinery we have now, factory, so you will have things like robotic arms, you'll have systems that move trays around in the habitat. You might even have robotic bees. If you don't have humans with paintbrushes, how are you going to pollinate some crops, right? And so you're going to have things that do pollination. Those are possibilities you can use a fan. But robotics, you could do a lot of pruning with it and stuff. But I think initially you don't need that many.
Right.
Now the robotics could be. Here's where robotics really would play a part: is setting it up. So when you're
Yeah.
constructing these habitats,
Yeah.
right, whether they're on the moon, on Mars, or rotating, robots can play a key part in setting up all the machinery to build that space farm. They
Right.
can
Yeah.
have it set up and initiated before you show up.
Yeah.
And so,
That'll
so
be
your first crops could be ready if you're going to Mars and it takes 6 months to get there. Maybe a year or two ahead of time, you've sent enough robots to build the habitat, construct the farm, and get it started so that the first crops come due right about the time you arrive.
that'd be fun.
Yeah. The other part is there's a thing called continuous harvest. So one of the things that we get out of the cannabis industry who happens to drive a lot of closed cycle agriculture, good for
Yeah.
them, right? Anyhow, they've driven a lot of the tech in this area. And one of the things you can do is called continuous harvest, where you harvest crops every day. So you have
Right.
a day's worth of wheat that comes mature, and then you plant a day's worth of wheat at the other side of the cycle. And
Yeah.
as a result, if you do it that way, and so on Earth, you have a thing I call it Big Bang harvest, right? Where you've planted a large field and then
Yeah.
you go through the whole growing season. So right now in Canada, US, you have winter wheat that's cooking away in the soil as we speak, right? It was planted back in October and it's now sitting in the soil as it grows in this huge field that looks like a big empty nothing, right? Maybe it has some
Yep.
stubble in it still, maybe it has some crop residue, but mostly it looks like nothing. And then you get to the spring and it looks like a big lawn. And then eventually you get to harvest time where it's amber waves of grain that you harvest out. So you have this huge area that for most of the year has these teeny little plants in it.
Yeah.
Right. So think of it that way. That's like a big bang harvest where I plant 180 days later, I yank the grain. Right. And so instead of that cycle, what you do is if you have an artificial construction, you can have teeny little areas for teeny little pots with teeny little plants or maybe teeny little rows for the
Yeah.
smaller plants. And then as they mature in cohorts, you move them forward and then
Yeah.
eventually move them to harvest.
I think I've seen that for like lettuce or something in a greenhouse where they had.
Absolutely. They do that for lettuce. Yeah. That is a classic crop, but lettuce has a very short growth cycle. It's only like 3 weeks, right?
Yeah. Well,
3 weeks from planting to maturity for most lettuce crops. Tomatoes, you start getting the first crop about a month and a half after you put in the initial
yeah.
sprouts, let's say. And then melon crops are about the same. So the things that I call like the fruiting vegetables, those are where you already do continuous harvest anyhow, where you
Yeah.
have a whole growing season and you're getting a handful all the time, just like the grape tomatoes I grow on my back deck. Right, the whole growing season, I get about a handful of grape tomatoes every day, which go in my salad. And
Right.
so those kind of vegetables are already in sort of in that continuous harvest mode as it is. And if the plants start aging out, you already have some in the greenhouse, you pull them out, stick them out. So those are easy, right? The vegetable grains, short runners like salad greens are easy. Microgreens, where you just grow it a little while and yank it, that's a short run too. But when you start talking longer crops like potatoes, wheat, rice, soybeans, them are all 120-day crops to 180-day crops. Maybe under
Right.
ideal conditions, 120 days plus or minus. And that's where this continuous harvest thing could pay off if you do it just right and you don't damage the plants in moving them through the cycle. The other side of that is plants at different time periods have different requirements for humidity and light. And that makes sense, right? In the early spring, light looks different than it does in the late fall. The humidity is different in the early spring than it is in the late fall. The temperatures are different early spring than they are in late fall. So this makes perfect sense to anybody who's actually seen a soil farm. So what happens is it's possible then you could optimize growth at each one of those stages using that continuous harvest model, where I have the lights tilted very blue and have a higher humidity environment for the younger plants. Move them into a middle stage where the light's very intense and has whole spectrum, or maybe slightly reddish, but whole spectrum for the most part. And then I move it towards the end where it's definitely shifted reddish and it's a very low humidity environment as I dry the plant out and force all the material into the grain product. Does
Like
that
August.
so a lot of crops have a dry out period. You'll notice this, right? It goes like this: you have exponential accumulation of mass, and then it gets to the end where it starts sloping off like linear, and then it stops straight flat as it dries off. So all the plant puts all of its energy into those seeds, and it's much more so for the ones we've optimized for growing on our fields, because a lot of our
Right.
grains, for example, are dwarf greens, 45% edible, 55% not edible, and that's about as good as you're ever going to do. That's about as efficient as you're going to get a plant to do. You might
Right.
get it to grow shorter, you might get it to grow faster, right? But you're going to that's about the efficiency level you can expect out of any plant.
Yeah. And then that all gets recycled inside your
Yeah.
farm.
On Earth and on Earth, your fields are far more efficient than they would have been even 30 years ago. Most crops are at least 33% more efficient than they were in the 70s.
Oh yeah. Okay.
Yeah, and in the 70s are far more efficient than the 40s and far more efficient than the
Oh yes.
1860s, right at the beginning of modern agriculture. So there's a huge efficiency gains in breeding and things like that have happened, data acquisition, different structures. And the other thing we can think about is carbon enrichment. So if we're going to be in an artificial construction anyhow, why don't we jack up the CO2 a bit? Some
Yes.
crops like it, some crops don't.
Oh yeah.
But
Some plants don't.
some plants give you a lot of greenery and not as much grain. It's a to be do. We don't know. We really don't know. This is an unexplored area for a lot of plants. Is how much CO2 is perfect, how much humidity is perfect, how much light is perfect. Some plants can actually grow better, a lot less light, almost on Martian light.
Oh yeah.
So you're talking Martian summer light might be enough for some plants to grow just fine, which means you could just put them in an enclosed greenhouse as long as they can tolerate the radiation environment. And you could grow them using ambient light in some cases. Now, the moon, of course, you can't do that, but you could do that on a place like Mars. And that's something you can do as well.
So talking radiation, how much study has there been on plants and radiation?
There's actually been there's actually been a lot of work in the ISS and with the Taegong stations on
Okay.
how plants react to radiation. The Chinese have actually done it on purpose. So they've radiated seeds and then taken the seeds and for good mutations as a result, sort of like a very rough version of knockout radiation mutation.
Okay.
They've done that. We've obviously grown things on the ISS left and right. Both of those are under the Van Allen belt.
Yep.
How they'll react to a lunar environment over the whole growth cycle, unknown. We have never
Okay.
sent a mature plant. We've never taken a plant and grown it from seed to maturity on the moon. Never happened.
More.
Nobody's done it yet. We've
Well,
sprouted them and grown them a little bit. Never gone any further.
there's
So
been
we
like
don't.
a handful of plant landings on the moon with humans at least.
But even in robotic craft, we've tried it in several robotic craft where we've had sprouts that have grown up, and they've
Okay.
seemed to do okay. The Chinese have done it too. Both the U.S. and Chinese with our landers have done that. We've done
Oh,
it,
okay.
done sprouts and grown them a little bit, but we've never grown a complete plant end to end. So until we grow a whole plant through maturity cycle, we don't know how a mature
Is it
plant will grow in that particular radiation regime.
And
But
then
if
you
you're
want
going to
to,
go someplace like the moon, you can of course stick it in a lava tube, and then you've knocked out a lot of the radiation problem.
right. And then also you want to do several generations to see if there's mutations happen, how fast mutations are happening.
And some of those would actually be good. Eventually, what you'll have is lunar rice, Martian rice, orbital habitat rice.
Okay.
Those crops will eventually be optimized for those environments. You'd be
Right.
silly not. And if you have radioactive exposure already, you're going to find mutations just in the process of growing them. So you could do old school selective breeding all by itself without having to get nuts about genetic manipulation, but we'd be silly not to use what we can. And there is already a lot of agribusiness that deals with genetic manipulation already.
Oh, yes.
This is not something we're new to. So it's inevitable that we will be selectively breeding and directly manipulating the genome of our crops in order to
Oh, yeah.
get them to grow optimally where we're putting them, and probably manipulating them to give us nutrients, maybe even taste preferences. Somebody
Yep.
who lives in a space station might have a different taste preference than somebody who lives on Earth. Over
Yeah.
time, that could definitely happen.
I was reading Chris Hadfield's biography recently, and he mentioned that when you're in zero G all the time, you want heavier spices, just because you
Mm-hmm.
can't, everything else tastes bland.
Yep, because your nose goes like this. That's exactly right. I heard that from Sandy Magnuson too. Same thing. They all told me exactly the same thing. Everybody, every astronaut I've talked to who's been up tells me when you get to microgravity, your nose closes up because you're not draining.
Yeah.
Where's it draining? And so your nose all closes up, and when your sinuses close up, then it essentially needs magnification for every possible flavor. So salt, tanginess, spiciness, right? You need to
Yeah.
do that so you taste something. And so their taste preferences are going to be different. That could be some degree different on the moon as well, right? 1/6 gravity, maybe your sinuses drain a little better, but not a whole lot better. So maybe you need that same kind of magnification versus maybe on a rotating habitat, you've got the right gravity already. You're in the right kind of gravity field, so your sinuses are draining right. But
Yep.
maybe because you're up there, you smell all these other things, and now you want something different. You also got to think about the fact that we don't just want a Western diet per se. I mean, we
Right.
have people that are going to be from all over the whole world. You already have this in all of North America, right? Canada and the US have a very diverse population mostly already. And so you already see this, right? You see a different series of dietary options already, which means you got to figure out which spices you're going to grow to meet those dietary options. And it's going to alter what crops you grow. Maybe I grow a lot more common beans. Maybe I need to grow corn so I can create masa. I don't know where I'm going to get the slaked lime from. I'd have to ship it so I can process the masa correctly. But if I want tamales for Christmas, which is my wife's heritage, right?
Okay. Yeah.
Then I got to have masa to make her tamales, right? And so, perfect example of dietary shifts, right? If I have a large population from India, they're going to want curry. They might have to
Oh,
ship curry up for a while until we get enough of the combination of ingredients to at least get close. You're not going to get a full curry mix. I'm sorry. There's going to be some spices that are going to be hard. You're going to have to ship them in, but we can at least try.
yeah. Yeah. We can try.
You're going to probably be making tofu. You're probably going to grow soy already because it's a great oil crop and a protein crop. You probably want to make tofu. And guess what? You make tofu in a bioreactor, right? You put it in a vat and you age it. Kimchi, same way. If I'm going to grow cabbage and I want to age it, guess what that is? That's also a bioreactor, right? You're,
Oh,
you're fermenting the kimchi in order to produce it. So we're going to have a lot of diverse cultures already. The larger the population, chances are the more diverse it's going to be with
okay.
diets. And people are going to want dietary diversity anyhow.
Oh,
You don't
yeah.
want to eat the same thing every day. So you're going to want to have a lot of different cuisine options anyhow. And so that affects a lot of food processing from the farm. It's not just, okay, I've grown the crop. Now the question is, what do I do with it? There's a lot of processing that happens to crops before you ever ingest it. And I'm not talking about chemical processing and making fries and things like that that you don't like to eat, maybe per se. I'm talking about the processes that already happen as part of natural culinary art. So, like kimchi, tofu, those are things that we already do, right? Those are things that we already have. Peanuts, maybe we get peanuts, maybe we make peanut butter, maybe we make satay sauce, right? Maybe we take some of the soy and make soy sauce. So there's a lot of processing options can open up a lot of dietary diversity also. Given something like algae, maybe we create algae additives. using yeasts. Maybe we create yeast additives. And of
Yep.
course, this brings up the other kind of bioreactor you're probably going to want: beer, wine, and possibly distillates, right? Those are all processing options for your crops.
Right.
So
Yes.
people are going to want all those same kind of things. There is another variable. If you have an orbiting habitat, how do you make money on the habitat? You could do intellectual property, of course, which is a great way, orbital banking, those kind of things you're going to do right away. I'm not even talking about picking up things on the moon or anything like that. Some of the earliest products from an orbital habitat will be data. But the other
Okay.
way to get money is going to be tourists. And so tourists have different things that they want. They're going to
Oh
want
yeah.
the local chow, whatever the local chow is. They want to experience things. When I travel somewhere, I want to eat the local cuisine because that's part of the experience, right? That's part of learning about what it's
Okay.
like to be in that place. So if I go to Puerto Rico, I want mofongo. If I go to Hawaii, I want poi. You get the idea. And so that's going to be something you got to think about too. If you're going to have a tourist population, maybe you start growing some luxury goods in your farm. For example, if you have starting with sterile regolith and I make my own soil, I could create a truffle garden and have my own truffles. I could have lunar truffles, I could have Martian truffles, I could have orbital habitat truffles. I could do the same with coffee. I could even have my own wine and my own whiskeys, right? I
Right.
might have a tavern, right? And if you're talking about a space community, which is what you're really talking about living in, you're not
Yeah.
talking about the sterile McMurdo kind of base. You're talking
No.
about a place that people want to live long term.
Yeah.
Then you're
That's
talking about it being a full community, which means you now want restaurant options, you want taverns, you
yeah.
want places for people to socialize. And those all have different demands on the farm as well,
Oh yeah. Yeah.
in addition to tourists, where you're going to have hotels and they're going to want the specialized, cool, whatever it is at your particular spot.
Yeah. There's already some startup working on space hotels.
Oh, yeah. That's been around for a while. You might be old enough to remember some of the scenes from 2001: A Space Odyssey. Now, I didn't see it in the theater. Don't get.
Neither do I.
I'm not quite that old,
I'm
but
not
I
old.
have seen it in reruns, right? And if you notice, there was a Hilton there
Oh, is
in
there?
space, and you flew Pan Am to get to it.
Yeah. I read the books actually. I
I
don't
did
think I've
too.
ever seen the movie yet.
Yeah, I read the 2001: Space Odyssey book, which is from the short story The Sentinel. But the point is, oh yeah, of course they're going to have orbital hotels, and
Oh, yeah.
there are already cruise ship companies that are looking at how do I do orbital cruises. They're already
Okay.
looking at how with starships, with other kind of spacecraft, where you take it and they look at it this way: they spend 1.4 billion for the average cruise ship. They pay it off in 5 years.
1.5 billion. Oh, okay.
1.1 to 1.4 is the number they gave
Well,
us, and the
okay.
return on investment is typically around 5 years. So there's money to be made. Let's say I have $1 million a tourist, right? I charge them 1 million for a 4 day orbital cruise. They're going to want to go somewhere.
Yeah.
They're going to want to dock somewhere. Maybe they
Right.
circle around the moon and dock there. Maybe they dock at a series of orbital habitats around Earth at a minimum. They become like the orbital Caribbean.
Right.
So you have tourist facilities, which will alter how you create some of the things in your habitat and alter your mass flow because now you got
Oh
tourists
yeah.
coming in with random mass flow.
Oh
But
yeah.
they could be, I mean, that could be good. That could be a good thing, right? Because
They're
they'll
bringing in
bring
extra
them with
carbon
that.
dioxide.
They're bringing their poop, if nothing else.
Yep.
They're bringing a day's worth of crap. And so you got that. Plus, you, of course, use that for resupply, right? They could bring up different things, but they're going to want things in return. And that's, like I said, coffee, truffles, wines, whiskeys, whatever. Maybe it's the local cannabis crop. I don't know, right? I don't know because we haven't done it yet. Maybe you have special mushrooms that you've grown that taste really good, right? Maybe you got the special oyster mushrooms that you've grown in your crop waste, and maybe
Yeah.
they have some extra culinary zing to them. Maybe that's what they bring home too. So they'll take
And then,
some mass with them, but they don't have to. They're going to take probably small mass, and in
okay.
return, you're going to have enough economics to drive a lot of other things. So tourists are going to be a thing on your rotating habitats, and
Oh yeah.
planning for that with your crop structure is something you ought to do.
Oh wow. Yeah. That's an idea. And then of course there's the all the zero G things that you can do that you just plain can't do on Earth.
Well, yeah. Initially, you'll have zero G halves, but eventually, hopefully, we have rotating ones. Because the
Well,
truth
like, I
is,
mean, when you've got rotating, there's still like the center where it's
fair point.
small gravity, but which you can do things like fly and
Yeah, very fair point. Yeah, the center parts can have gravity of various types. Intellectual property is one of your biggest exports because you can have different gravity regimes and you will
yeah.
discover different things from microgravity all the way down to 1G. So, intellectual property is going to be a major export, just like it is from space now. Space exports huge amounts of intellectual property and a whole lot of it. So, no reason that the orbital habitats wouldn't drive that exact same thing, right? Lots of intellectual property plus tourism. Them are going to be your economic drivers. I speak at a
That,
science fiction conference once a year where I'm in the science track. And this
mhm.
last one in October, I did one on what it would take to build a Death Star sized station.
Oh wow.
I talked about what it would take to build a 2,000 kilometer sphere with a certain percentage solid. Turns out you got to wipe out Mercury to get enough mass. But
Yeah.
I also talked about 1,000 kilometer rings that you would rotate. O'Neill, how much of the asteroid belt you'd wipe out, how many rings you'd get. I'll send you the Frizo. It's something I did, just sort of a silly rule of thumb kind of thing.